Okay, if we're going to do this experiment at home, the first thing we're going to need is what's known as Newton balances. These are things which will measure weight. Now, we have scales that will measure mass, but we need things that will measure weight. And we're going to try and make them with these fairly well available things now. Toilet roll, they're just the centre, the other bit's obviously far too valuable to waste on this. We can use elastic bands. We can use even Nico-elastic, you know. I'm sure your parents could find some of that from somewhere, but I'm going to use these comic balloons which are left over from a children's party some years ago. You might remember that the clown spends a lot of time stretching them, so they're very springy. First thing we have to do, that's it. The first thing we have to do is to make holes in the it's not So now we have two Newton balances with an elastic section and a string at the bottom to carry the weight. Okay, and welcome to the upstairs hall, the landing as you like. Here we're going to do the experiment on this. As you can see, is a rail for clothes, a clothes rail. You have a clothes rail in your cupboard, a lot of you, and if you don't, you can take a few clothes out and use one in your mother's, sister's, whoever it is, more sensitive brother, whoever it is. Anyway, so these hanging rails are absolutely perfect for what we're going to do now. We are going to calibrate these things, which means we put the scale on them, okay? Now, at the moment, there is nothing on either of them, so I'll mark them on this piece of paper I've hung in the middle as 0. Okay, I can do that on both of them. That's our 0 mark, you see. Now, I'm going to hang the smallest weight I have, pecans. Okay, there we are. The pecans hang. As you can see, it goes below the level. You can just see the mark there, I think. So I'm going to make another mark now, and I'm going to call that 100. I'm going to do this one in grams and convert it to newtons at the end. So that is 100 grams of pecans. I now have 200 grams of sunflower seed. A certain vegetarian theme is emerging here, I think. I put another mark, and that's 200. There you go. And finally, I use my favourite. Take that off, it won't come off, there you go. This is risotto. I do like a bit of risotto, right down to the end of the piece of paper. So I can make the 300 mark at the very bottom there. 300. Okay. Now, I need my old bamboo. Old bamboo. No? No? Never seen that movie? Very good. Very good. By the time we're finished doing all this, you'll have seen every movie ever made. And that one. Chitty chitty bang bang. So, now I have my old bamboo. My old bamboo. I have to balance the bamboo on my finger to find the point at which it balances. I then mark that point because that is part of the weight. So that is going to be where, that's the centre of gravity. That's what I've found by balancing it on my finger. And that centre of gravity is going to be the point that the mass of the bamboo has to act. Now, and then measure the weight of the bamboo, the mass, with an electric scale. Now, as you can see, I have suspended the bamboo from the 2 Newton balances, and if those with eagle eyes will notice that they are no longer at 0 because the mass of the bamboo is pulling down the Newton balances, already registering some weight, some gravity, some downward force. Now I arrange various of my things. So now I'm going to arrange my nuts so that the bamboo will hang straight. This is always important. Always arrange your nuts so that the bamboo's straight. If the bamboo is horizontal, the distances you read are perpendicular to the forces, perpendicular to gravity and to the Newton balances, and you can read the numbers directly off of the scale. However, if you don't arrange your nuts so it's horizontal, you have to do trigonometry to find the perpendicular distances, and nobody wants to get into a bit of trig, do they? So there are my sunflower seeds. Over here I'm going to put my pecans, and just to confuse matters I'm going to use 150 grams of good old-fashioned hazelnuts. Now, a little bit too much weight at this end, push it a little bit. Does that look level to you? Not quite, I don't think. There we are. Now, what I need is my measuring tape, and I will measure the position from the end of each thing. So, for instance, the hazelnuts are exactly 25 centimetres from this end. I'm going to take moments from this end, so I'm going to write it down. And I record each one. I record distance and weight. And with these, I record distance and reading. This one is 32, this first Newton balance, and it's reading about 280. This one's reading about 250. They don't have to read the same. So I've been measuring these. I've made a little chart, and I am completing the chart now with the last measurements. The last two are for the centre, which is at 45 centimetres. And 45 centimetres represents 0.62 of a newton, that's 62 grams, roughly. And the last piece here, which is at 72, and that's our pecans, so that's exactly 1 newton. I've roughly estimated 100 grams to be 1 newton. That's pretty much it. Now we move on to the calculatory phase of this experiment. So I have carefully recorded my information, and now I'm going to use it to find if the 2 laws are proved. The first law, forces up, forces down. So let's look at what are the forces up. The forces up are here and here. Simply 2.8 and 2.5 newtons, giving us 5.3 newtons. The forces down, well, there's 4 of them, 1.5, 2, 0.62 and 1. And that, of course, equals 5.12 newtons. So, with an experimental error, I think that's reasonably good. Now, I want to do the second law of coplanar forces, the so-called law of the lever. Moments, in fact. And I'm going to take moments around the end. Moments about 0, here. So, I want to first of all do the clockwise moments. The clockwise moments will be all of the ones pulling this way, in the direction that a clock's hand would go. So the first one, at 25, is 1.5. So 25 times 1.5. I continue with the others. 41 times 2. And then I also have the centre of gravity to add in, which is at 45 and is 0.62. And then to that we have to add the last one, which is at 72 and is 1 newton. Now, if you, like me, have left your calculator at school, here's a fine free calculator you can use. 25 times 1.5. So after I've done that long boring calculation, I get 219.4. Well, the units are Newton centimetres, because the force is in Newton, and the lengths are in centimetres. Now for the anti-clockwise moments, well, there's only 2 of these, of course. We have the 2.8 times 32, and the 2.5 times 57. I did this already, and it came out to 232, Newton centimetres. I think, just within 10%. Yes, I think that's just about 10%. So an acceptable value. So, within experimental error, the two are equal to each other, forces up and forces down, clockwise and anti-clockwise moments. Notice, I've always used the units in all my calculations. Now you can do this one at home. You don't have to have balloons. You can have anything. You don't even have to have nuts.